Okay, so this is the panel on the interpretation and interpretability and causality. And as we've already seen throughout the last two talks, this is a very contentious topic and lots of things it's easy to disagree on. So yeah, so I'm happy to have Joe and Alex here. And let me start by asking two basic questions about causality. My first question is there really a cause? Like, we are searching for the cause, but does that entity exist at all? Is it defined at all before? And my other question, which is kind of related, is I think that there is a role here to human perception. What humans will say, what humans will accept, what humans can conceive as a plausible cause, and what is the role of the human perception in our notions of causality. So let me start with you, Alex.
That sounds great. I feel like I'm much less knowledgeable about this, so it's good that, yes, the quality will improve over time. Yeah, I mean, I guess, it seems that the framework of causality or I guess the frameworks for causality have been defined, at least in the statistics world, right? If we think about the Neyman-Rubin model or Pearl's models, they are focused very much on this notion of an intervention. And, I think I feel relatively satisfied with a notion of causality that allows me to predict what the outcome will be in a world where I apply an intervention. And this, I think there are many different places where this can be problematic. So for example, if I'm doing astrophysics and I claim that there's some causal relationship between things, I am not going to be able to fly in a spaceship and push a star into a black hole or something. But I think to the extent that we are willing to agree, and I guess this is sort of the human element of it, that there is a notional intervention, and this is the outcomes of this are what we are trying to predict, right? So there's something that, at least in principle, could really come to pass, and we could predict it before we see it. Then I'm sort of happy with that as a notion of causality. So it's a very forward-looking notion, though. So I'm not exactly sure how to reconcile that with something retrospective, like explaining why this particular thing happened.
Right, because I mean, I'm looking at us here, and I'm seeing your beautiful black hair and the white hair of Joe and me. And now we can ask, what is the reason that whatever remaining hair we have is white and yours is black? And if I say it's age, oh, you cannot intervene on age. You cannot take someone and change their age by keeping everything. So age is not the cause for our white hair?
So I'm going to start by copping out and say that if we're looking for the reason that something happened, that we get that this is like a case where we're doing a retrospective analysis. And I guess, right, if we wanted to do a forward-looking analysis, we might say, right, that we could try to predict the color of my hair if we put all of the cells in my body in the state that they would be in after, some period of time. I mean, I actually think that age is sort of an interesting question here, because there are all of these notions of biological age that that folks in like biological sciences, or you talk to somebody who's doing metabolomics, will talk about, right? And I think that we are actually trying to abstract the mechanisms that we're thinking about when we say that age is the cause of this issue or that issue to particular mechanisms that are going on inside of cells. And so I think we might not be able to say that the time since my birth is something that we can intervene on, but we might be willing to agree that there are some intermediate factors that are actually intervenable, and arrive at a more precise discussion of cause that way.
Yeah, so
I guess I largely agree with Alex. So first, let me go back and say you know, are there really causes? There could be multiple causes. That just make sure we're on the same page. But, you know, I think cause, I'm not sure what it means to say there's really a cause. On the other hand, it's an incredibly useful construct. So, you know, whether in nature there are really causes, I don't know how to answer that, but I can certainly say that for people to structure the world in terms of causality seems incredibly useful. You can see it, you know, little kids try to figure out causes, right? They play with things over and over again, see what happens if they intervene in different ways. I think there's a good evolutionary reason they're doing that. It's a useful way to understand the world. So in terms of Shai's, you know, particular question about, you know, do we want to call age a cause? My answer is that it's a useful construct, and it's useful precisely for the reasons that Alex said, that if we think of age as a cause and maybe we can't intervene, you know, I wish we could. I'm 25 again, but you know, can we? So what we're really looking at, we're using age as a high level, you know, macro variable in some sense to represent a bunch of features, just as Alex said. And if we think of age as a cause, it makes us think, well, what specific things that seem to be highly correlated with age can we maybe intervene on to stop our hair from turning white and falling out? And it's, again, a useful construct. So yeah, let me stop there.
Yes, go ahead.
So I read from Nancy Cartwright's papers that I think she defines causation as like you have enough evidence to act. So can we have the panel to discuss also, it's not as a dichotomy, yes or no, but it's really a continuous spectrum that's I'm kind of holding. And then you see enough evidence, and then you decide that, like as Joe is saying, it's a useful construct, have enough evidence, I'm going to act on it. So it doesn't require to be true, but it's really like precursor to action.
Okay, so being introduces yet a third element. It's not just a question of our perception, but it's also a question of our ability to act, to cause a change.
So let me first answer your second question, which I realized I didn't answer, you know, in terms of our perception. So I want to go back to David's talk, that I think a big deal in our models was the choice of variables. And I think the choice of variables is strongly influenced by what you can perceive and what you can control. So this is maybe coming back to Bin a bit, that there's this famous story that I think it's due to actually Denis Hilton, Dennis Hilton, but I think he's actually French. And there's an accident, and a road accident. People are asked what the cause is. And the structural engineer says, oh, the road was designed badly. If there hadn't been a sharp curve here, you wouldn't have had an accident. The auto mechanic says there was a problem with the brakes. The psychologist said the guy broke up with his girlfriend, he's depressed. The sociologist said, you know, there's a pub near the highway, he's been drinking a lot, and maybe because he was depressed. My point here is not that any of them is wrong, but they're each structuring the world in a way where the variables, it's not so much what they perceive in this case, but the variables they feel they have control over. So the structural engineer talks about the cause being, you know, the shape of the road, because that's what he feels he can control. You know, the psychologist talks about the guy is depressed because that's what he feels or she feels she can control, and so on. So if we think of this as a useful construct, part of the construct says that the variables that we choose will, of course, depend on what we perceive. We don't want to talk about a world, you know, in terms of variables that don't make sense to us given our perceptions, but also we use variables that we feel like we can control, because these are the ones we feel we can intervene on.
But not in all cases. If I say that a tsunami caused some destruction on the beach, I cannot control the tsunami.
Okay,
I still
maybe
say that the tsunami is the cause, and I cannot also do
I tell you, even
counterfactuals
there, we
with the
would say
tsunami.
that quite often we say things like that in the context of, okay, what are we going to do to prevent a tsunami from happening next time? Right? That identifying the tsunami as a cause, I think we have a desire to understand the world in terms of causality. So quite independent of changing the world. I mean, okay, I'll speak for myself. I like to understand why something happened, even if I have no hope in hell of doing anything about it. So,
Right.
so I grant that. But still, I think it's often not unrelated to, or at least, maybe evolutionarily, that desire springs from the feeling that if we understand what the cause was, maybe next time we could do something about it. So I'm not sure, to answer Ben's question, at least from my perspective, I don't find that a useful definition in terms of working with it formally, but that's just me. But I do think we definitely care about causality in terms of how we can affect the world, so that thinking of the extent to which we can affect the world is, I think, very useful. I just wouldn't call that the definition of causality. That's my taste. That doesn't feel like a useful definition to work with, but
I feel like where I stand, it's very useful. I like the formal definition of the philosophical discussions, but from where I am, it's very hard from this simple example to translate to something, say what genes to intervene on to see whether cardiovascular health, right? It's just not as simple, and the definition don't fit. But this evidence for action just speaks to me as an empirical kind of scientist very clearly.
I'm not sure they're that far apart, because I could say things like, what's the probability that this intervention will cause that outcome? And I would be perfectly happy to say that.
But the thing is, we have multiple probability models. I can have 17 different models for heterogeneous variety. So it's not that simple. What's the probability either?
Okay, that's fair.
And then you have this different randomized starting values, and you have different data perturbations. So quickly, what the probability means becomes slippery. And then, but in terms of evidence, I'm kind of more on the quality side, and they make sense to me. It could be just me not understanding all the fine philosophical points, but I feel like there could be a good, like both could be useful. See whether the panelists will agree with me.
And the only thing I want to protest is when you're saying it could be me not understanding the philosophical aspects. I would say that if you do not understand those philosophical aspects, then it's a fault of the philosophical arguments.
I'm with Shai. I mean, I have no problem. I'm not a philosopher, but
You want to add something, Alex?
Oh, no, I do think that there's something to this in terms of perhaps right, trying to move back from defining a very abstract concept of causality to just saying that yeah, this is the information that I need to reason about the implications of an intervention. So I can see where the where the motivation for that definition is coming from, and I would like to read more about it.
Yes.
So one question I have, should I take the mic?
Someone like to volunteer to be the mic runner. Zach was great at it this morning, but
Yeah, I think I'll just sit up here so I don't have to bring it all the way back up. I mean, there feels to me like a bit of a disjunction between the notion of explanation in terms of interventions or causality that we've just talked about now, and the notion of explanation that we talked about in the morning in terms of AI. So thinking about this as a mathematician, I think, okay, suppose you gave me some complicated looking function and you said, hey, I noticed that it takes a value equal to 0 or very close to 0 at this point. What's the explanation? Now I might say, oh, my explanation is that that function actually factors as a product of a bunch of linear forms, one of which vanishes at that point, like one of which is 0 at that point. That feels to me like an explanation. It has nothing to do with intervention or causality or anything we've talked about, but in some way it feels rather close to what we would be saying if we explained why a neural net produced a certain output. So how do we square that? Is that kind of explanation what we're talking about at all this afternoon, or is it just like a different thing that has the same word in it?
Yeah, I think actually we touched on this a little bit earlier today, right? When we asked whether there's a relationship between thinking about explaining a model to learn something about the world versus thinking about explaining a model to sort of simply summarize what this complex black box is doing. So I guess it was like explaining the model versus explaining the world. And in trying to formulate my talk, I struggled a lot with trying to figure out which of those I wanted to talk about, because at least in my mind, they seem to be quite distinct things. Although, right, as we talked about this morning, there seem to be some connections between them. But yeah, I think you're right to notice that there's definitely a divide there.
Yeah, so I was definitely focusing on what I would call a causal explanation, because largely I think that's what people are looking for in cases. So I take your point that you know, if I'm teaching mathematics and I want to say, okay, why is this polynomial zero? A good way to think about it is it factors into a bunch of linear terms, and sure, set x equals 3, that's 0. It's not, it seems like a different flavor of explanation.
Can I try to blur that a little bit?
Okay. Sure.
Because I do a bunch of work with ecologists who are really interested in mechanisms that maintain things like biodiversity.
Uh-huh.
And so let me imagine, let me tell you a story that's kind of a simplification of what they do. If I've got a couple of bacteria species that eat the same set of nutrients in a petri dish, but one of them is active during daylight, and one of them is active at nighttime. Now, for reasons that I can't, for other reasons, I can't maintain this experiment unless it's outside. So I'm not able to explicitly intervene on that. Nonetheless, the fact that there is variability in light, or I could talk about it as temperature in a natural environment or something like that, right, is a reason that these things coexist. Even though there is no world in which I can make them not coexist.
So they occupy different ecological niches somehow?
Yeah, no, effectively, you know, temporal variability in the environmental conditions produce varying ecological niches in which each one has a differing advantage. The point is that I have to have a model in my head that says, what would this world be like in which I could fix the environmental conditions that would then produce it, even though that is never actually realizable? What is this world like in which I could make you forever 25? Right? Is the same thing. And
wait long enough, the Earth will become tidally locked.
So I'm not sure it's ever not about a model.
I mean, for me, definitely everything was relative to a model, so I have zero problem with that. So I'm in some sense,
And so then the question,
as opposed to
what we
what?
say, is it an explanation of reality, or is it an explanation of this? I mean, you know, for why is this zero? Well, there's a factor, and if that factor was not zero, you know, didn't hit zero, then this function wouldn't be zero. There is the same operation.
Yeah.
You can play the counterfactual with the function. You can play counterfactual with the function, but you cannot play the counterfactual with the biodiversity. That was said.
Well, you can play the counterfactual in your head.
In my head,
And,
yeah,
and
but
I
not-
think so the argument is all of these are about counterfactuals in
Right, but
some
this
model
is-
that you have,
this
and
is
whether
some
or
kind
not you
of-
believe the model actually corresponds to reality is really the only thing that we're talking about as being different. Or whether I can achieve that counterfactual in terms of bins, can I make this actionable?
But I cannot use the counterfactuals in order to validate or falsify my model because I cannot activate it.
That's correct.
Yeah, I guess this feels like it has a very similar flavor to the age question that we had before, right? Yeah, in the sense that you could also say, okay, what are the set of factors that I think stand in between the day-night cycle of the Earth, right, and whatever stimulus the bacteria are responding to.
I would argue that don't need to make that plausibly achievable in the real world. You just need to have an imagined world where it exists.
I guess what is the I may have lost track. What do we need it for?
In order to maintain coexistence.
In order to maintain coexistence.
In a constant environment, one of them will go away.
Or sorry, in order for the like the day-night cycle to be a useful explanation for coexistence.
Yes.
Yeah, I mean, I think that makes sense. And generally, it does seem like if you are explaining things that have already come to pass, right? I think that a model is sort of a necessity, at least from sort of the highly simplified structural causal model sort of world, right? That is the kind of question where you would actually need to specify a full structural causal model, right, in order to fully specify like the probability that you'd like to specify. So, I mean, I think that there is actually potential to formalize this intuition that like a model is necessary there.
So I would think that you can have multiple models, right? And I only care about the parts that they consistent, the rest I just leave it for further evidence, right? It doesn't have to be one model, right? You agree, right? That,
Well, wait, so my definition of causality, end of explanation, is relative to a model. I mean, that's actually critical. And now you can disagree about whether the model is reasonable. You can look at multiple models and say, okay, it's a cause in all of these models, but all the definitions are relative to a single fixed model. You can have uncertainty about what the model is, right? In the epistemic state, although I didn't talk about it in the talk, you could say, well, I'm not sure what the model is. Probably one third is this one, probably 2/3 is that one. And it's a cause on both or neither or whatever. I took your question at the beginning, Shai, to say, what about the real world? And is it reasonable? And I think there's sort of an interesting tension here a bit between your first question and Giles' comment that certainly nothing in my definition says the model has to have anything to do with the real world. But I mean, at some point, we would like to connect the claims we're making about causality to the real world so we can ask, are we going to allow all interventions in a model? What if an intervention is not realizable in the world? Is it still okay to have that in the model and so on? So we've actually, now we have a slightly more general notion of model where one of the features of models. And so what interventions are you allowed to do in this model? That's just part of the definition of the model.
but even in your one model world, right? You have uncertainties, right? So you have
uncertainty about the
already.
context. Yeah.
So qualitatively, you're already moving from one fixed probability distribution to a bunch.
I have no problem with that.
Yeah, then that's probably share similar structures, but if you go there already, why not also include different versions of, say, card models, right? Who have similar structures, but maybe a little different. So I think if you accept that there could be multiple models, even in your world, then that means we can have meta level multiple models too, with different structures. I'm just pushing the multiple model view.
Yeah, was the question there? Yes, go ahead.
Runners in force. The first thing I would just observe is a lot of the things that have come up. When can you intervene on things? Is that necessary for causality? The distinction between metaphysics and epistemology of causation. Are models necessary for counterfactuals? The difference between a model of the world and a model of an algorithm. There are large literatures on all of these things, and at least I'm happy to give people pointers to them. We don't have to necessarily reinvent wheels here. I guess the question that I have, though, maybe for both Alex and Joe, is To what extent interpretability, explanation, causality, this sort of cluster of notions, both of you have very much emphasized the pragmatic aspects of it. Joe, I 100% agree, about that we are wired to view the world through a causal lens in many ways. Alex, you were talking a lot about the value of action in the world. Does that mean that notions of whether you want to do causality or explanation or interpretability, I'll let you pick which one you want to talk about, are tied to the cognitive constraints of us humans? Which is to say, is it the case that when we think about how should we use this, maybe I'll make it more practical. How should I as an ML person use this kind of thing? Should I say, okay, well, people struggle with causal models with more than about 5 variables, so therefore I just need to restrict my causal models in these ways? Should I be using the cognitive constraints at all when I think about interpretability and explainability?
I mean, which brings back to the original question I was trying to pose. I mean, what's the role of the cognition or perception of humans in those notions?
So in terms of, I think, I'm harking back to my days with my PhD in math, I want to have a general enough framework where I certainly want to define causality in models that are not bounded in any way, saying, at most 10 variables. For interpretability, where now you're talking about what's, comprehensible by humans, it would certainly be a real feature if you could explain things using relatively few variables or get a good approximation, just because if the goal of interpretability is to have people understand, people clearly are going to have a lot of trouble with a model with 100,000 variables, right? But I think that too, I mean, the whole point, or a major point of our notion of abstraction, was to say when a small model was sort of a good abstraction of a much more detailed model. So if you're going to look at interpretability and say, look, I've got this model with 5 variables, it's not exactly right, but it gives you the main idea. I would hope that we can make precise in what sense it's giving you the main idea, right? Not just to say, well, it's close. I mean, but here, I mean, it really is an abstraction of or an approximate abstraction of this model with 100,000 variables. In this very precise sense, it's really giving you the main idea, right? So that if we as scientists are going to push for interpretability and say, look, we only want small models because that's all people are going to understand, at least we ought to be able to make a connection. If we as scientists understand that the small model is, I mean, it's not the exact right causal model, but there's a sense in which it captures the main idea, we ought to make precise what we mean by that, right?
That goes back to David's talk in the morning,
right,
that small model depends on the variables.
Absolutely.
And then your
so do
choice
big
of
models.
variables is crucial here. It could
Right.
be a small model with respect to some variables, but a very large model with respect to other choice of variables.
Yep.
I generally agree with everything that Joe just said. I think the reason that I brought up causality in this talk was mainly as an example of a way of distilling a model down to like a scalar value, for example, if you're just looking at a treatment effect, where we've sort of worked out the set of conditions where we can map this summary of the data to a concept that many people can agree on as being sort of important. And in the way that mapping is constructed, puts a bunch of conditions on the data generating process and just the context in which in which this summary is being deployed. And so I think there's sort of an orthogonal question about what kind of summary you should be pulling out versus the context in which that summary is going to satisfy a purpose. And yeah, I feel like I wasn't terribly clear in my talk that what I wanted to do was to say that causality or causal inference is at least one case in which there's been a pretty deep discussion about what it takes for that summary to actually serve a well-defined purpose.
Yes, go ahead. Simon.
Thanks. So I think it might have come up in different ways and came up in the morning. So some people think that maybe we look at what counts as a good explanation or what counts as a good causal identification of the cause, and that can kind of unify many of the things that we want in interpretability. So I want to get to your opinion in terms of whether thinking about what counts as a good explanation or good selection of the cause or good selection of the relevant counterfactual is actually something that unifies our different aims in interpretability, or actually should push us to pursue completely different directions. So
Can I just ask that one more time? I'm not quite
so
sure.
here's another way of asking it. Tosca asked the question that the experiments where something bad happens and people focus on different types of events as either being the cause, and there are similar type of findings in counterfactual selection. So something happens, people think if only this could have been different, and people focus on many different things. And it turns out that they focus on things depending on what their aim is, whether they want to learn from the mistake, whether they want to hold someone responsible, whether they want to blame somebody. And in interpretable machine
I think
learning,
this is similar in spirit also to the
Exactly.
story about the car accident, right?
yes, all the Kahneman Tversky and
Yeah, right.
everything that follows from that, and the other car accident. Yes, exactly. So the worry then is that even when we are focusing on explanation, kind of counterfactual causation, it seems like that is kind of underdetermines the set of things that we can choose. We have to add this other layer on top of it in terms of what we count as successful explanation, right? So do you think we can have a general theory of what that other ingredients is? Maybe this question came up in the morning and now I'm just throwing it back there. I thought we couldn't, but maybe you have better ideas.
So let me give you one reason it might be tough. So one thing I've looked at, suppose you have a sequence of more and more refined models of the world. What I mean by that is, I describe the world using 3 variables and say, okay, that variable 3, if I look at it more carefully with a microscope, I see it's really made up of variables 4, 5, and 6. Throw out 3, replace it by 4, 5, and 6. And you keep getting more and more refined. And I actually have an example where there's A and B, is A a cause of B. And as I have a sequence of more and more refined models in a very precise sense, each one is what a logician will call a conservative extension of the one before. So that as I get more refined, I'm not losing any information, I'm just getting more detailed information. The question of whether A is a cause of B flip-flops. Yes, no, yes, no, yes, no, as I get further out. So in other words, as I look at the world in more and more detail, the answer to the question is A a cause of B just changes back and forth. Now I have conditions on which that doesn't happen. I actually have theorems, but that observation gave me real pause. I mean, not only is it saying that the way we describe the world affects how we think about causality. Here we're looking at the same events. It's not like in your example, David, where we're just describing the world using sort of different sets of variables. And so here, all the models have A and B. They're all talking about A and B. And they're all asking the same question, is A a cause of B? Is A equals 1 a cause of B equals 0, or whatever? And the answer, and each, as you're going out, each model further out contains all the information in a precise sense of the previous model. It just goes into more detail in some sense, right? And the answer flip-flops, and that makes me really nervous about what is this saying about causality. So I don't have a good answer to the question. I'm just pointing out that here's a technical issue that I don't think has gotten enough attention, actually. What counts, the answer to the question is A a cause of B is not only is it model dependent, it's model dependent in this horrible way that more and more detailed models give you different answers.
Let me just try to, I think here we kind of again go to this question of whether we try to explain the world or we trying to explain the model. that it looks that the phenomena that you are describing is when we try to explain the world and not so much when we're trying to explain.
Yeah, we're getting more and more detailed models of what I take to be the same world.
Right. And for maybe to both of you, but there is another aspect of it. If you're trying to explain the model, to interpret the model, it relates to the issue of strategic behavior. Like if we have an explanation of the model, then someone can come and game the system and try to go against change the result of the model for themselves. So it goes to the question of robustness or strategic behavior. And I just want to pick on this question of how does interpretability relate to robustness of the model and to the ability to game the model, and maybe the explanation is of the model is changing as the people are trying to game the model based on the interpretation.
So what do you mean more precisely by game? I understand intuitively, but could you maybe give an example of the kind of behavior you have in mind?
No, so say you find out that you want to accept students to university, and you find out that the number of books that they have in their parents' house is a good predictor of how well they're doing in university. So this guy that wants to be accepted to school goes and buys a whole pack of books. And now he's
He takes a picture of his parents.
Right, right.
And sends it along with his application.
Yeah. So
there's some economist who says, as soon as the criteria for decision become known, they become useless. I forget the exact quote, but it's a wonderful quote.
Right. So is the interpretation, I'm trying to change the focus back to the interpretation of the model and the implications of interpreting the model rather than the difficult question of interpreting reality.
But they're related though, right?
They're related.
Like, I think there's this movement broadly in that literature on interpretation. It's like broadly, there is this literature. I think, that there's antecedents in economics and mechanism design, and maybe like the sort of FAIR-ML literature is kind of like late to the party, but this literature on strategic classification, I think Moritz was here until recently, was, maybe stirred up some interest in this idea of like, well, let's say you're making decisions and the criteria are known and the people subject to it, like each X is actually some person and they have the ability to manipulate their features and some cost model. And the like first naive approach is just to assume that like there's no causality whatsoever. These are just measurements, and they're measurements that are being messed around with. So it's just totally a matter of like gaming. It's purely like a Goodhart's law kind of thing. And then, a next step refinement is people start realizing, well, like, that sort of misses the whole reality of how we make all decisions that we always make. Like anyone who actually makes real decisions, whether it's school admissions or hiring, everything, does it very consciously of the fact that people make changes. And some of these are actually, this is the very reason very often for making the decision in the first place, like performance-based pay, whatever, anything like this. The whole point is we make decisions for the very purpose that we know we're consciously engaging in like a world where there is strategic behavior, and we want to set a set of incentives that bring about the behavior that we want. But then, right, but then once we accept that like what our model is it's not just a model in the supervised learning sense, but it truly is a mechanism, then we sort of are brought back full circle to this thing that we are modeling the world. Because if the modeler is not modeling the world, then they're just stuck in this bullshit, you know what I mean? But it's like, it is the fact that like, it says that what it is to actually operate intelligently in the system is to have models in the first place that are, whether or not you believe you'll have the full description of all the world and I have God's SCM in my head, that in some sense my model is capturing some important parts of the world such that it leads to the kinds of interventions that bring about the things that I care about, right? I don't know, sorry, just want to interject a little bit. No. We should have the question afterwards. I don't know if someone wants.
Hey, I just wanted to bring up, there's lots of examples of what Joe is talking about, of things flipping back and forth as you go to more detail. We see it in healthcare all the time. And in fact, I wanted to ask about this, so I'm glad you brought it up first. We see, for example, I'll give you a really simple version. If you have pneumonia and you have asthma, your chance of dying from pneumonia is less. And doctors, when they see this, want you to immediately fix the model because they believe that having asthma is in fact a serious risk factor for pneumonia. Then they explain, well, what happens is the asthmatics, when they come in for care, one, they get to care faster because they have a doctor who treats their asthma, so they know who to call. And then because they're considered high risk, they get really high quality care. And that's enough that it flips the sign of asthma from being a very negative risk factor to now being in aggregate a positive risk factor because it causes you to get to care faster and get high quality care. And then if we add those terms to the model so that it now thinks that asthma is bad for you, but rapid care is good for you, high quality care is good for you, then they no longer want us to correct the model. And yet the funny thing is, so this is exactly what you're talking about. One is a more refined model of the other, right? Because asthma is causing high quality care and rapid care. But the funny thing is they want us to correct the model if it has just asthma in it, because that just doesn't satisfy their biological understanding of things. But if we don't have the two variables, speed to care and quality of care, in fact, the model is still causal. Having asthma really does lower your chance of dying. If you could cure asthma, the benefit of asthma would go away. Or, if you could treat asthma in such a way that it had no longer an effect on these other things, then the benefit would go away. So it is truly causal. And yet in one case, they like the explanation, the more detailed case, and they're happy with keeping the model the way it is. And yet in the other case, the model that's a slightly less refined version of the model, they actually want us to edit that model, correct it, make sure it doesn't do that anymore. And yet statistically, they predict almost the identical thing if you don't edit them. And if you do edit them, they become different. So then we see many examples.
Yeah, absolutely. I mean, I think, right, this, when Joe was mentioning his examples, I immediately thought about this question about causal pathways, right? Because you can have multiple causal pathways that come from a single variable that have opposite signs for the outcome of interest. And then, yeah, depending on which mediators you condition on, yeah, you can end up with the remaining, like the residual direct effect of your original variable having a different sign. And yeah, I think this does sort of speak to the issue that the variables that are in your model really do define like almost implicitly, right? What you are going to call a cause and effect, right? So similarly to our question about age, right? If we could identify all the mechanisms in a cell that are related to senescence, and we could condition on those, then age would be independent of hair color, right? And so, right, I do think this is a really important point, right? I think similar, your definition of explanation, right, depends on what the person is conditioning on. I think this, right, this does sort of, it all seems to fit together rather nicely.
What's so disturbing about it is that in one case, the doctors are happy with the model.
Yeah.
And in the other case, they tell us we have to change the model.
But isn't it because asthma is carrying the signal of the very decision that they're ultimately trying to make? Like, I think the doctors are right. And what you're looking at is that asthma is like, asthma is the confounder of the treatment. I feel like this is a problem that sounds like, right? Like, I feel like it sounds like perplexing, but like, this is like I feel it's like a textbook case of like a case that's given a clear.
It's absolutely textbook confounding. What's disturbing is that if asthma usually means you get the treatment, then you should be happy to leave in that asthma is good for you in the model, because you'll usually get the treatment and you'll usually then benefit from it. But in that case, the doctors tell us, oh no, you have to change the model.
But the reason why you want the risk score is to guide the allocation of the treatment. Then then you want that this means that asthma means you're high risk because so that you'll continue to allocate the treatment. Like it feels like you just wrote it up. Like this is a case where I feel like the DAG is really like
The DAG is very informative.
yeah.
So actually, our group recently put together a paper that I just found out is accepted to a KDD workshop about this idea that when we're producing predictive models for medical settings where we think that the model is going to be used to allocate treatment, we absolutely should be including the treatment that was received as at least a way to contextualize the predictions in the model. Right, so even if we're not sort of including in the model the fact that treatment was received as like a conditioning variable, if we can at least include in the model or sort of package with the model a prediction of what treatments this person would receive in the training data that we saw, then I think this could potentially sort of solve this issue, right? If you are delivering a little bit more context in addition to the predictive model, then I haven't done the UX study, right? But perhaps you would find that doctors would be more accepting of the asthma model. But I agree, this sort of highlights this very human aspect of what constitutes a good explanation.
So to add to that, right, at least it's the biology, our biological system hasn't changed. But then there's a whole time dynamic, right? So cancer treatment, something just stop working after 6 months of chemo, right? So then we have the world like changing because of intervention. So then that's a more complex situation and it's a lot more challenging, I think.
Yeah, I think that's right. We had a question. Did you still have a question?
I think I was just wondering how much we should also like look at the dynamics of the explanation because in that example it seemed like depending on what the model is, the treatment changes. So we should probably take a model that kind of is where like the model is kind of stable in what. Or like I think you kind of addressed the point already because you said like we should include the treatment. Yeah, and it seemed to be very related to the strategic setting. Yeah, and I think something else I wanted to ask before is whether we should, for thinking about useful explanations, always assume what is the action space of the person we are giving the explanations to. So if it's a practitioner who tries to make their model better, then it should be something like what more data should we feed into it. But in other situations, when we try to give explanations to people who are classified, then the strategic setting that Shai was mentioning might make sense. So I kind of felt like a lot of what you were saying kind of related to that for a useful explanation or like a measure of goodness is the action space of the.
I see. Yeah. So yeah, this is related to the car example that we look for explanations. We look for models where we can intervene and do something useful. So I think that's right. That a model is more useful if it lets me understand what interventions I can make that are feasible for me to change the world. I mean, that's not the only reason we use models. I don't mean to imply it, but certainly in many real world settings, I think that's true, that we're mainly interested in building models that allow interventions that are feasible for us, right? So.
I think we're out of time. I mean, it's very exciting and interesting, and I hope that people will keep discussing it during the reception and in the
Right.
following days of the workshop. And I want to thank you very much for your
Thank you.
talks and for the interesting discussion, and to thank the audience for the interesting comments and questions. And let's go to the reception. Thank you.